Hi there. Don't mind me, I am just doing my thing here. I'm a little bit late and I'll tell you why. It's because my cameras and things didn't work starting off. Hey Dolan. Also, I was posting something to the Patreon. Having done those things, we will move on. You might notice a little more in the way of background noise, or possibly not. I can't really tell. The background noise would be because I have a ceiling fan going and an intake fan also going. It's going to be another hot day. It's been really weird stacking so much firewood, even though it's hot days, but I'm getting prepared for the winter coming on. Now let's see. I'm going to want to bring up my chat window. There we go. And we can definitely converse about, let me see, first of all, I got to set up the little window like that. You might have noticed from the last plugin thing that I've now got this kind of craziness going on. Not a lot of noise. Good. There's going to be background noise there, but as you know, when we're referring to things, I can make the audio be pretty extreme. I'm now curious what I can make happen out of this silliness. One thing about this is my video feedback thing seems not to be exactly working anymore. Like, I can get an image and I'm streaming, but it's not giving me a live image, and I don't really know why. Yeah, we don't need that. I'll just set that to something else. Oh no, it's the video rate. It's going to go crazy. Oop. Yep, sorry about that, folks. Yeah, it's all about me setting this thing up. So that I can do plug-in videos, and I've been working on having the green screening for that work out better. But we don't actually need to be running it. So let's switch back away from that again. Yeah, we're here to code a plugin, not to play with video things. As much fun as that is. And if you really wanted, I could, but we're not going to do that. The software is not software so much as it is a Eurorack module. And it's not exclusively a Eurorack module, but it's a thing called a Sleepy Circuits Hypno. And it's a Eurorack compatible video generator. I think it's cool too. I like it. So let's see now. I'm gonna scooch my laptop over so that I can actually work with it, because that would be good. And we'll kind of gradually get rolling with this. I can't go super late today, but I can do a couple hours or so. And I'm going to try to set things up so that I know what the hell I'm doing. Let's switch over to this. And as soon as I have it showing that on my little monitor-y thingy, I will pause the controls so that I don't distract myself all day. And there I am in the corner there. We'll just get to work. So I've updated the title of the stream to relate to what we're going to be doing today. What we're going to be doing today is ZHighpass. We're getting into those Z-plane filters. Let me see, I have a note tucked away over here. I made this little note for myself from another note, which is the stuff that I recorded the other day. So let me, option click hides that. So here's what I've got today. Let's make sure that I can play it. We got a little clip. And you can hear this weird little jam. Because this is roughly equivalent to what I put into the sampler, the E6400 or whatever. And what you can see now is a big pile of clips from the output of the sampler. I never managed to learn how to save anything. I never managed to learn to use it in any kind of sophisticated way, but I got far enough to be able to sample into the machine and then use the internal gain thing to clip stuff, and then assign the playback so that I was playing back approximately the right note, and assign a modulation wheel to filter cutoff. And that means I can do this. This is the real sampler. It's not a plugin. That's the output of the real EMU E6400 Ultra sampler. And these are the Z-plane filters people wanted. That's kind of the whole point. So Z means I'm trying to get these sounds. I'm not actually emulating the sampler in the traditional sense. It's much more sort of black box reverse engineering. I'm using my techniques to try to get these sounds or as close to them as I can, because one thing I've learned is in doing this kind of stuff, it's more important to retain the tone quality of the digital signal than it is to model all the little components and things. So we're going to be doing it that way. Here's another example. This should be a fourth order low pass. So this is the sound of a real Z-plane filter. Now you'll notice there's a difference in the underlying audio, and I can explain why that is. Because I took the raw clip, sampled it into the EMU, and then started applying gain. So here is the same set of filters. I'm not really interested in doing plugins where I really tried to model something, and if I did try to do that, it was a long time ago and it didn't work out super well. I'm more interested in modeling the sounds that we can create out of these things. So let's see, bandpass second, fourth, high pass second, fourth. So this would be distorted, but not as distorted. Second order low pass. Fourth order low pass. You can hear a little more of it this way. And I'll tell you why I'm doing it the way that I'm doing it. Sixth order. Anything crunchy you hear in this is the real device. So that's the target. This is what I'm going to be trying to get to. Thing is, I'm not doing the low passes first. I'm going to be doing the high passes first, and I'll show you why. Here's one of the high passes. And let me scooch this over so that I can see what I'm streaming. Yep, see here? Look at this. Initially in the capture of the audio, these things were all 6 dB louder than everything else. The high pass had a bit gain thing going in there where everything came out exactly 6 dB hotter, including this. And this is the fourth order high pass. See that? See the peaking? This is out of the actual device. And it's captured at a really low level too, so this is not the ADC distorting or something. This is what the output of the EMU does when you do this. And when we zoom in, we see that with this distorty stuff, the bright stuff is peaking way hotter than everything else. This is not too dissimilar to what I had with Macity. And we can continue to scroll in a little bit and look at what's actually going on here. This is being captured at 96K. And we can see just a lot of hot peaks on this. I didn't actually have other kinds of test tones. I'm more interested in these audio signals and working with these. But this should be enough for me to go forward with. And I will skip over to stuff like this. Or better yet, let's go back to the one I called Meltdown. See, Heavy Dist was taking this sample recording it in, and then putting like 24 dB of raw digital gain on it. Meltdown is taking what that was and putting another 48 dB of raw digital gain on it. And that gives you a really good idea of what the filter does when you overdrive the filter. And overdriving the filter is what people were doing to get their sounds out of this. So you got your bandpass, high frequency bandpass is peaking a lot hotter. And we can measure how that works. Like if we have the bandpassy stuff there, and then it gets brighter, we need to make our emulation do that. And likewise with our high passes, here's our high pass just going into complete and total meltdown. What that looks like, it looks kind of like this. This is the waveform of an emu just flipping out. Now, so that this is the second order, this is the fourth order, and here's our low pass. Distorted that heavily. And you can see we have a really interesting variety of things. Like when we peak out super hot, it gets louder, but then also when we hit low frequency peaks, that's actually peaking hotter than the raw mid-range stuff, which is acting a lot more like flat topping. And it's not going to be perfectly flat topping, but it's acting more like flat topping. So the EMU as a synthesizer is giving peaks that are real different depending upon how high or how low you get. It's able to peak out real hot when it gets bright, and that's why we're looking at high pass first. But the low pass algorithm, here's a good place where we can see some things. And by the way, this is the kind of stuff where the drum and bass guys, they wanted to make basses that were this. And they'd repitch it or whatever. But you can see very similar things to what we had in McAdee, where the super distorty stuff, there's like spikes on the edges of the flat topping. We've got waves that have become square waves, and they're not perfectly clean little square waves. In fact, some of this stuff over here, when it gets a little more freaky, this is basically the reconstruction filter doing this. So we may find different ways of accomplishing the same basic result. But what the EMU does when we get this kind of nonsense going on, the EMU is taking raw input and doing the biquad filter, and then also throwing this strangeness on the output. And that's what having the hardware versus just taking some kind of digital filter and applying that means. You can see how kind of raspy and funky it is getting into this kind of stuff. So the goal is start working with my plugins and then tune them so that the biquad part is approximating what this does, and the analog emulation part, namely the McAdee style part, can produce these outputs. Like if I've got a low pass and I'm going down to here, it needs to be able to do that. Whereas if I'm doing, say, a high pass, high pass needs to be able to do this. And this is going to explicitly show me what goes on when we're going into the really high frequencies that way. So I need to start out by tuning the high pass filter that I've started with ZHighpass, and it might not do as much in the way of weird biquad filter stuff, but I need to get the biquad filter stuff basically correct, and then tune the analog stage after it, which is initially coming from McAdee, so that it more closely replicates what we've got here. That's probably where I'm going to be getting this result. So first thing that we'll do is start trying to build this. And my hope is that I'm going to be able to get something happening today. I mean, we're about a half an hour in, and we've got something, but we don't necessarily know what it is yet. But I'll tell you what. Here's our audio clip. And if we were to do this, there's our ZHighpass, and that's what I had it set up to do. So input gain and outpad are from the instance of McAdee in there. Freak should be doing the filter, but it's not yet, possibly because poles is not set to anything. Now the real one doesn't do this, so we're going to have to fix that. But so that's one of the first things we got to do, is take away the X series freakiness. It doesn't do that swoopiness. So time to throw a little change in there. There's also something else that we can do, which I think would be relevant. A couple of things, actually. And one of them hang on. Okay, McAdee output. We're going to want to take this, move it up here, because we're going to want to saturate going in to this stuff. So both of these are running in parallel. We don't necessarily want that. We don't necessarily need pad to be here, so let's just remove it for the moment. We're going to rapidly try to hack things into condition. That means that no longer does anything. This doesn't have anything to do with the stuff in here. I don't think we actually want to... the sign is what's causing that freakiness, so let's take that out of all of these. We can probably leave this as the 4-stage thingy so that it has that Airwindows capacity to blend between stages of filtering. That will actually let us go to a higher order of high-pass filtering than the real thing would. So the key there is to have the intermediate settings of this control sound like the hardware. But extreme settings of the control will not sound like the hardware anymore. And I'm going to steal this. Actually, you know what I'm going to do? I'm going to update all this since we're no longer using sign for that. And I'm going to update this in all of its places. And then I'm going to put it right up front too. Although one thing I can do is before I do that, we'll see what we get out of just one stage getting heavily saturated. See, there we've got our little clip. We can actually grab this if we want to use it. So let's see what we got. We needed to implement that, didn't we? Oh, I see. We're diving right into wordless zone right from the get-go. But that's going to be necessary because this is an important one. Like, if there was ever a plugin where I had to be on point and like not be able to communicate in English the entire time, it would be this one, because people really want this result. And all of the other ones hinge on me being able to get the analog emulation right. So having copied that over, I kind of want to make it so that I can reach what I'm doing. Just give me a second. Go to full with this. That can sit down here for the moment. And this can sit here for the moment, and then I'll be able to reach them. And now, if I fire this up, there's our audio clip. There's our ZHighpass. We're not distorting this, but I still don't know whether it's freaking out at high gains. I'm guessing that is going to be freaking out at high gains. That seems loud. We're not getting louder as we go high in frequency, which is wrong. I hear a sort of squelching noise in there. Yeah, we're definitely making a squelching noise. So my question becomes, at what point is that a problem? And can I make it entirely go away by clipping it from the get-go? That's a good thing to find out about, I think. Let's copy this out of our clip stage, since we wanted to say input sample, and paste it into here. Now, when I'm boosting the in trim, I'm just doing raw digital sample going into the high pass. Now, one of the things that does puzzle me about this is I do kind of need to be able to make it get really loud. Oh, hello, lows boost. That's not relevant to what we want. Let's make that go away too. So raw filtering into raw MACD and then so on. And MACD's got a couple of things going on with it. We're going to want this to be a fixed thing because this, as far as emulation is concerned, I keep staring at my own face in the screen. Like, me pointing this way is me looking at where I am on the screen. That's ungood. Let's scooch it over a little bit so I'm not distracted by myself. That always happens. The camera's there, not there. Honestly, that's not that bad of a thing to not be making eye contact with the camera. A lot of broadcasts and television and stuff like that, you routinely are looking a little bit off, getting interviewed or whatever, and that's fine too. But I just always, when I'm staring at my face, moving and talking face on a little screen elsewhere, it's like, this is not great. So, onwards. I just removed lows boost because I don't want lows boost. Let's see what we got. I prepared a little bit in advance because I wanted to have enough time to actually get somewhere. I didn't want to spend too much time like all setting up. So we're getting a gnarly distortion effect in the filtering. And we can make it go loud. That's good. We want that. But we want it to go loud when we go up to the super high frequencies, and we're not doing that yet. Also, we got a kind of a weird side effect here where one pole is giving us some things. It's getting much louder with this, and then it's getting quieter again. So this is sounding a little bit like the sounds I was expecting to get. But the amount of sheer distortion we have on this, let's see what it's doing overall. So where is this hitting? We're going to do an apply and close at this setting to see what the edges of it look like. And then we're going to not save, we're going to quickly undo. And what we've got is not what we necessarily want. Like our boost is definitely hotter than the low frequency area, but not by nearly enough. Let's get out of here again. You'll also notice that I'm doing the raw multiplication version of power this time. Which is mostly because I was sort of like, why not? Sure. I believe that doing the raw multiplication version of power rather than the power function is less mathematically correct. And I think that is something worth maybe expending the extra cycles on. But for this is not necessarily the most mathematically correct sampler. It's an old sampler with kind of crude implementation. So we might want it to be like that. There's also another thing I wanted to try. I wanted to see what I'd get if I assumed that the real thing was using very low quality biquads. Because I might be able to make it kind of break by doing this. We'll see. I should be able to just straight up recompile it. And let's see whether it's acting any different or sounding any different. And we're not even to the stage of comparing it to the real thing yet. We're not even in the ballpark. We're really far away from getting this anywhere. I'm not liking how the super high frequencies are not distorting harder than the rest of it. This is backwards. I need to make it act differently. And I'm going to assume that that lies in the high pass in some ways. So there's some adjustments to be made still. As for the changes I made here, I can probably keep this. I'm not sure if it's actually going to make it run any better or worse. But I know that the actual sampler does not have long double processing. So you'll notice I'm leaving it for the analog modeling phase, because that's meant to be a processing chip rather than an old sampler calculation. But the other stuff I'm going to leave as a lower quality calculation, and we'll see whether as I get closer that causes me problems. So here's the thing. We're doing this processing and we're clipping inside every stage. Do we want to be clipping inside every stage? What happens if we get rid of that? Oh. Well, what the hey? And then see what we get. Will we be maybe, and input sample times trim is going to be a thing. Where are we getting trim? We're getting trim is 1.0 plus 0.5 minus biquad A. So trim's getting smaller. That's not right. We don't want that. Let's reverse it. That's going to change things. That's going to change things so much, maybe we want to put this back before doing our next experiment, because that was a very big change. So we're back to hard clipping at every stage. That may or may not be what we actually want, but we're going to probably want it to match every step of the way. Hey, Jack. Yeah, you're welcome. I hope to do many further things much like that. For now, we're trying to get into the zone of a classic analog, classic digital sampler. Because if we can do this, we can do it for a bunch of different things. Alrighty, so back into the breach. Again, we're not even referring to the real thing yet. Frequency can start off as a very low frequency. Let's start off with no gain, and let's go. That's distorting. That's real distorting. It gets a lot quieter as we boost the highs. We're going to need to I'm not sure about this part. Although I do know that we got to boost that trim a little bit more. Let's do that. See what we're doing every time we have a stage of EQing? Oh, hello, or do we? Not every time we have a stage of EQing, but almost every time. Let's change that. Because we're still trying to figure out whether this is functional or not. There, now they all match. I think I stopped that because it wasn't working right with the dry wet. In fact, I'm pretty sure that's what it is. That you had to have full wet on at least one stage for that to really... So maybe, Now see, we've got lots of clipping all through here. And we've got clipping on the input. And the question is, what are the thresholds here where it's going to clip right? And trim is Y, we're clipping more and more as we go. So let's go into trim again. We'll get rid of this for now because we don't use it. Trim of 1, of course, is going to be unity gain because we're multiplying by it each stage. Plus biquad A means it gets higher and higher as we go. So biquad A is always 0.5 or less. If we multiply it by itself, it's going to have much less boost. But if we multiply it by 2, it'll go to closer to, hang on. It's going to go closer to unity gain, which plus 1 is doubling the gain. So we've now increased the amount of boost a lot by high frequencies. Let's just start working really fast because my English is losing me, or vice versa. Target here needs to distort louder when it's bright because the real thing from the real sampler did that. We got our nasty distortion. We don't necessarily want it to be doing that. But what happens when it should be able to distort harder. It's doing some good things here, but let's fool with that some more. It keeps distorting so hard. Let's trim this some more. Now we've got this under control. And let's just go and refer to the super distort version that we had before. This is the real thing. I don't think it's sweeping up quite as high as my real plugin is. And we can distort very hard, but it's not freaking out the algorithm until you sweep up into the super highs. So here's the thing. We've got this super distort, and we've got the filter which distorts inside itself. Now that I've amended this, it should be able to dial down this control, which can start at 1, but then it becomes less. And at low frequencies, it'll not distort, and then at high frequencies, it still will. So the way this is working, we're clipping inside the filter. We should be able to distort it without making that swoopy noise. That's one concern. And sweep up to the extreme highs where it'll start distorting way harder. Right now, we're causing way too much at these lower frequencies. It shouldn't be doing this. And that's the raw distortion. As soon as we kick that in, we've got that going on. And there's our one stage. So that's not resembling the real thing at all. This swoopy noise that it's making, which is part of distorting the actual algorithm. What's causing that is both trim being increasingly boosted inside here and this distortion stage continuing to be hit every step of the way. So one thing we could do is not clip that. If we simply don't clip it, we'll get our trim boosted more and more, but not in quite the same way. So now we're doing our distortion on the input, and then we're running through the high pass. The high pass no longer has a clipping factor, but we're still boosting trim every step of the way. This ought to make something happen, and I'm confident I'm never going to need these, so let's take them out. We're going to keep simplifying this as we go. But at the point that I'm sure we're not using a certain thing, the certain thing just goes away. So, trim contains, where did it come from? It came from here. Contains parameter 5, which is going to be 1 for starters, and I can make it be increasingly smaller as, what that does is that lowers the overall offset, like 2 times biquad A means I get more and more boost as I go up in frequencies. Let's boost that even more. And then I can make trim all the way down to 0 when biquad A is small enough. And that means as we keep going through levels of filter, it's going to cut the amplitude back. And let's see what we get. Now, if I'm correct, that prevented the sort of crazy sweepy noise, the nasty. We've been replacing all of our low end with a filter chirp. That filter chirp is not present in the real thing. So if we're doing this, we can distort, but now we're not getting the filter chirp. What happens with our filter frequency? How about full crank? Interesting. Oh, wait. I could give it more poles. This is only one pole. This is starting to sound a little more like what we're talking about. Unity gain, or thereabouts. So let's exaggerate it super hard. If our poles are cranked up literally all the way, this sweeps up higher than the real thing does. I might need to change that. If it's going to be the Z thing, it needs to be confined to the limits of what the real thing had. So it sweeps up to around here. That seems like it might be in the zone. Let's see whether this correct value is actually 0.5 exactly. Now we're doing our maximum number of poles. So let's get into our boosting world again. I think our lowest setting is around here too. So we're starting to get a little more in the zone. Only thing is our trim needs to be higher to duplicate what I'm doing with raw meltdown. Or meltdown, not raw meltdown. Raw meltdown is raw. I'm also speculating on whether I want this to be smaller. Let's boost it even more. Trim is our gain level stuff. And just for fun, let's see what we get if we have only one clip stage right out front and everything else becomes a normal biquad. Like if we're clipping only going into it, because I know that was a thing, but I don't know how much of a thing it was. This could teach us some things. We have a glitch here. This is not supposed to be happening. That's not supposed to do that. That's pretty loud, but we're starting to get into the zone where, as we sweep it up, it's trying to get louder, but it's not really succeeding. Let's maybe fool with another experiment. There's a variety of things I need to change here. Everything is going to be evolving a little bit as I go. So we're assigning this, but it's going up too high, so we're going to call that more like 16K and see if that sounds right. And then we also have a minimum, but just assigning it to this isn't necessarily great. Since we're limiting that, let's hardwire this. Then we don't need that because we already know it's going to be at least this. But then we'll have a full range of adjustment, and we could also sneak it up a bit and see whether the low frequency area is right. We can also put that on another. Some of this needs fooling with. Hang on. Gonna need to label stuff. This is a suitable place for this. Then this is a suitable place for this. So we're going to be looking to parameter 3. But we can't just use parameter 3 because it has to be a lot smaller. So what we're going to do is throw it in some parentheses and then multiply it by. That way, full crank, we should be able to lift that cutoff into the mid-range. And at 0, we've dropped the low frequency behavior right down to the bottom again. And we don't need that because our biquad is always, all of these filters were Butterworth. That's why they say second order or fourth order is its variations in Butterworth. Which is interesting because maybe we don't want exactly Butterworth. Maybe the way this gets its sound is it isn't exactly Butterworth at all. If it was just 0.7, what would we get? Actually, no, it needs to be steeper than that to be. Time to refer back to the raw sound. Time to refer back to the real thing. Does this sound like multiple layers of Butterworth, or does it sound like something else? These are our high-pass filters. That's supposed to be second order. For only a single order, well, second order filter, that sounds a little steep to me. And this, I'm not at all convinced that these are Butterworth stages. I'm not at all convinced that these are really Butterworth stages. So let's go back into here so that I can see what I'm doing. Parameter 6 is what I'm going to be looking for here. And we're not even going to be doing this. Instead, we're going to be doing this. Now we got all kinds of things on little controls. Yay. And let's quickly build it and play with it a bit and see if we can sort of get it roughed into the correct zone. So here's what we've been changing. This needs to be set to 0.707, which is the previous value, pretty much. More than that is more resonance per stage. Gain trim, I think this is what we had before because we just doubled it. That's interesting. If our pole is next to nothing, we're not even getting the input gain. That's so clearly wrong that I have to address it right away. Maybe we want to always be running the one filter. Because that's kind of my concern. I think maybe that's too far away from what the real thing would work. Oh, hey, only down to 3 people. It's probably because I'm talking such nonsense. We will try nevertheless. I'm interested in figuring out how to make this all work. For now, let's ignore that part. I'll just make a mental note that I might want to remove that dry stage so that if you have it engaged, it's always going to be engaged at least somewhat. And that's going to be 0.25. So that might be a thing. This is showing me where it kicks in, and I think this is a reasonable place for it to be kicking in. That said, the clipping that I have here is clearly not helping me at all. We are doing the clipping, but nothing about that is actually good. So let's go back to no clipping inside, even though it's supposed to be clipping inside, but I just don't know. That's not giving me the results I need. Now that sounds a little bit more like it. That sounds like roughly the rate of it. I think we need a lot more gain on it. And it only goes up to about here. We need to continue dropping this a little more. Let's try 14K plus whatever param 3 is. We haven't even started fooling with our resonance yet. This is weirding me out a bit because I know that it needs to be clipping inside the filters somehow. Maybe it's just a matter of me not being able to boost in trim inside the filter. Let's cut it and then see what we get out of just a single trim in front of everything. I'm not sure that's going to be right either, though. That said, we can still be hard clipping all the input stages at the place in the code where supposedly the emu does it. Let's have a quick listen to what that sounds like. We're now boosting kind of into it, but we're not continuing to boost over and over again inside the filter. we've got an increasingly steepening filter every step of the way, but we're only boosting into it once. Hello. That's interesting. That's a nasty high frequency scrunch. That's kind of what we were looking for. And that's relatively clean. What happens if we do more poles? Interesting. This, dare I say it, might actually be starting to behave right. I think we need more total gain. I need to just nuke it. But remember how we were going to fool with the Q of the stages? What if Q was 1? That simplifies the code. Hello. We've got our nasty scrunch, and it's more accurately depicting what the real thing would be doing. Pole's gain trim is what's going to help us here. So if it was lower, we have a cleaner low frequencies area. And if it's higher, hey, it's a great essay. You're quite welcome. If you will sub on Patreon on Friday, you will see some of my more recent notes to people on the Patreon. Oh, that's interesting. We can get a nasty behavior going. This is interesting. We're starting to get into the zone now that I've set the Q to 1. Hey, David. Hey, man, there's like nobody left here, but I don't know if people are showing up a little bit. This is us working on the hopefully accurate. Oh yeah, you're going to need to be multiplied by yourself here. I can tell that right away. When I say you're going to need to be multiplied by yourself, what I'm talking about is this little place here. If I can find it. Let's see, where are you at? This is the amount of gain going into stuff. This is the total amount of boost. Trim is where it kind of starts as far as the boost is concerned. And multiplying by biquad A means it's more boost the higher frequency you get, but it's not steep enough yet. So we multiply it by itself, which also means we're going to need to have this be even larger as well. And that is, tell you what, let's put everything on a control. We're trying to dial in a complicated behavior that rides on freak, so, or we'll call it frequency. So frequency low offset, that's just the pitch of frequency. And seven, max high boost. Meaning that I now got to go and grab get parameter 7. Here's the format I'll be using for it. That needs to replace this. But rather than being 32, we're going to have it be even larger and then dial it back. So now what's going on, and it'll have to be 7. We're getting a little scattered here, but trim, get parameter param5. Param5 is the smallest amount of gain for this. 7 is the largest amount of gain that's tied to the frequency control. So when I put 7 higher, then I'll be able to kind of dial up the amount of boost on specifically the highs that are also being high boost multiplied by itself. If you're not following this, don't worry about it. This is always really challenging. And this is what we got. So lots of gain, very little gain. So that's how much boost we've actually got. And it's getting smaller. It shouldn't really be getting much louder as I go here, but it is. So worry about that later. This is limited by how much pulse gain trim is. So at 0, we got nothing. We're going to want it to be about this much gain. Which it is, so that's cool. And then, as we filter it, we start making it more and more distorted. And that's what the resulting thing does. But then when we distort everything, we're going to want it to go up to about here. And this is how distorty we're making it when we crank it up like that. Firstly, let's maybe dial back the frequency even more again, because the real one simply doesn't go as far as that. I'm a little concerned about how this interacts with get sample rate, but not super concerned. Because this is setting a frequency regardless. So let's take that down even more. Because one thing I did notice is that when you do the actual filter, what was that noise? I'll worry about it later. Could have been something outside. When we scale this at higher sample rates, such as we're running, the real sampler filter doesn't actually go to a complete cutoff. It swoops up to a really bright sound, but it's not going out of the human hearing range. So we're going to want our control to act kind of like the control on the real device, seeing as that's the purpose of this expenditure. That sounds about right. Hold distort. We're clipping around here. We can also make it flip out like this, but we don't want to. That's about where we drop off. That's the max, and that's giving us some distortion. Now, if there were Butterworth, we'd have this, but it's acting like it's a little more than Butterworth. And we know that it's throwing these nasty artifacts. So let's do one further thing. Since we're using Total Meltdown, we're going to just briefly fuss with this. We got Mackety stuff up here. I'm not exactly sure what 48 dB is going to be, but it's going to be more than this. So what we can do is boost in trim up a little bit, and then it gets multiplied by itself, so that's going to give us a big result on the output. And that should get us into this zone. This is our steepest filter. Hang on, that's the band pass, I'm sorry. This is the high pass. So we need to do this nasty behavior. This is the real thing. It needs to be that kind of excessive, and it needs to be that tonality. And as it sneaks down, we're getting kind of normal clipping. That's as steep as we get. That sounds super resonant. That sounds so resonant that I'm not even sure that my limitation on Q is enough. So let's extend it a bit, shall we? Here's our resonance. And we will go from Butterworth through 1 to slightly above 1. And that's how much resonance we will get, because that sure sounded like a bunch of resonance to me. It really did. That sounded way more resonant than just Butterworth filters and high passes. We've got our extremely high gain on tap. Let's build this, or rebuild it if I hadn't built it before. Put it in there and see whether we're starting to get into the ballpark again. Again, if this is not the most entertaining stream, that's fine. This is some serious work. See, that sounds a little like it. So I can tune that in. And I feel like I still got a lot of gain in here. Okay, we're starting to get into the zone a little bit. Only thing I'm thinking is it feels like the resonant frequency of the analog output stage might be a little steeper than even what Macity was. Let's take a moment to go even more nutsy. Check this out. In trim. Where is our in trim? Here, or is it not? No, it's not up there. It's down here somewhere. Here's our Macity stuff. There's in trim. Hi there, we're going to do this twice. So now we've got a in trim that will go to stupid levels of gain, which should hopefully replicate the amount of gain I threw into the meltdown clip. Again, well, let's first build it and throw it in so that we can switch to it rapidly. So here's the thing. Can we replicate, let's see, second, fourth order, this. About how much gain is that? So this is the sound I'm going to want to duplicate out of the control settings I have on cap. Because this is out of the raw sample that's distorted really, really hard. I should be able to get about that much low frequency rumble, that much overall gain, which is 24 plus 48 dB, which is a lot. And then we're going to try to tune in the highs to more accurately represent what we've got there. So let's give that a try. Here's our original sound. Here's our input gain. Here's our frequency. It's not as low as this. This is with maximum poles. At 2 poles, it's like this, which seems about right. This part is not right. I'll have to deal with that. Let's dial in the correct amount of Q now that we've got the sort of input gain dialed in. We'll do that by opening this up again and being able to refer to it. Maybe I'll copy it out into another file so that I can have it just there to play with. No, document with selection. Okay, here's the real thing. So fourth order. Let's find roughly that amount of resonance. A little less than this, I think. Could it be exactly 1? Yeah, we're taking 707 and we're adding this to it. I feel like it's still going up a little bit too high in frequency, but we're starting to get into the zone where it's sounding. But our top end on the cymbals is not quite right. And I feel some of that might be a factor of the McAdee stage afterwards, which will require its own little adjustment. So let's quit out of here for the moment. I'm not actually saving the reference. This gain stuff, I can make anything that I want later. I can always go into it extra hot. Dry sample can be the clipped input state, which will fix some of this stuff. Maybe. It's a bit of a problem. Figuring out how this works is a bit of a problem. So let's see, where were we at? Trim is our frequency trim. We're not actually clipping anywhere inside here, but we're clipping the outputs. Oh no, come to think of it, we're clipping everywhere inside here. What am I talking about? All of these stages are internally clipping and they're starting to behave the way I wanted. So that part's probably fine. My only question becomes, if we're slamming this so hard and we're clipping the internal stages, as we are wont to do, and we have filter resonance, but our filter resonance is maxing out at 1. Let's take this back out. This goes back to full crank. In fact, let's not even worry about that. Let's assume that 1 is the correct value for this, meaning we don't need this. That is most definitely not using a Butterworth slope, but it didn't sound anything like a Butterworth slope, so there you go. We got this going on, which is all well and good. Where are we at? We've got 2 different roll-offs, which I think we arrived at by kind of tuning them. Here's our first biquad, here's our second. They're both at this frequency, which we don't necessarily want, but we can also tune that in later. Actually, what am I talking about? We could tune it in right now. But here's one of the things we were going to do first. Our frequency should not be power factor that steeply, because it's giving us this wide range, but that's not consistent with how the actual device mapped MIDI input in. The original device mapped MIDI input in quite differently. I also feel like I can take this down to around 11K. It's going to end up being a little smaller still. So this 2-factor thing is giving us our frequency range. Any further adjustments can do that. We're starting to get some of this stuff sitting right, or at least pretty close to right. And we know that our biquads are clipping internally, and we're starting to get the right behavior from that too. Namely, we can hear in the real deal example, it opens so slowly that when we clip it, we're getting that nasty, chewy crunchiness. Now, one thing that might be fun to do is let's look at what this looks like on span. There's a lot of gnarliness in there, and there's a lot of boost going right after 20K. This is the real thing, remember. So this is our EMU brick wall filter. And when it swoops up to here, and then there's artifacts from distorting the DAC. That's what this stuff is. So we need to put that in there too. By contrast, what we have in our plugin so far, and we can do maybe another half an hour of this. Hopefully I'll get far enough that anything further is just tweaks and adjustments, and we can move forward with it. This gnarliness is the stuff that's supposed to be beyond the band limiting. This is stuff is contained within the band limiting, and my slope on here is still not right. Frequency needs to be even shallower than that. I'm thinking frequency is going to not even be a power factor anymore. We're just going to use raw Get param2. Or, I think I'm going the opposite direction. I did that wrong. But making it much more of a power factor and seeing whether that's restricting our range. And while I'm in the middle of doing that, as always, I'm going to do several things at once. I have two further things. Op-amp free and op-amp Q is what we're doing for the filtering on that final stage. So we're going to start adjusting that stuff a little bit, because it was definitely happening a little bit less in the real thing. So we want 8 and 9. We might want a more resonant effect out of it. Here's our Macity stuff. Let me just copy that stuff. I'm a little too distracted to do that from memory right now. Where was that? Where are you hiding? There you are. Throw that stuff in there. Maximum of 20K, and we wanted 8 and 9. And since biquad F is already kind of hot, let's comment these out and just straight up replace them with something. So I see that these are, this one's shallower, this one's steeper. That is how I did Macity, so we're going to preserve that. Rather than having them be exactly the same, this one's going to be steeper. Oh, hey, let's do one of our favorite things. Golden ratio, or thereabouts. If that sounds at all good, I'll replace it with the full-on golden ratio, just because. Because all I really know is this needs to be larger in biquad F than it does in biquad E. And none of them need to scale up quite this much, but this will help us dial in the amount. Hey Aiden, it's been a while. Yeah, well, people have been dropping in and out. This is apparently not one of the most exciting live streams to watch, but I'm trying to cover a lot of ground as far as starting on the emu emulation things. And of course, like I said before, that is through my way of doing things rather than copying their code or their circuit. And we've had some useful discoveries already. For instance, I wouldn't have guessed that the high-pass filter that they did was clearly not made up out of Butterworth stages, but it's not. And it seems like it was made up of stages where the Q factor is 1, which probably makes it easier to calculate. So we shall see. It may be that because that is easier to calculate, I might be able to simplify the code in there a little bit, and then it will run more efficiently and have some things in common with the real code as well, if that is in fact what they're doing. So, back into this. We have now got op-amp freak, which would have been like around here, and op-amp Q would have been around here, and this is going to affect our brightness. as follows. We can make it be much darker, or we can make it be a little brighter. And we can boost the Q, which is giving us a lot of extra gain. See, the trick with that is if I dial in the op-amp modeling, which is some very simple algorithms, for this high pass correctly, it will also have the correct high frequency overtones for every other filter that we do. That's why high pass is first. We're dialing it in such a way that I can get this to behave. And let's get our reference file in here. Let's make a double reference file while we're at it. New document with selection. We're going to save that as, I'll probably do that for all future things, just focus in on the one that I'm working on because it'll open faster. And let's save it as flat just because. It'll take a little while, but it should open fairly well. And give me my back. Give me this back. This goes over here. Now when I need to open it up, it'll be a little easier. And that should be fine. I'm not really sure what its little problem is. And over to the calculation. How are we doing with our voicing? Compared to, oh hello, are we not working somehow? Do we need to quit and start over? Let's not. I moved that, it shouldn't have changed anything. What do we got? Or compared to. It's actually a little quieter, strangely, but even though our gain levels are somewhat unpredictable, and I'm really not sure why I'm padded that hard, but I'll worry about that later. It gets more distorted as it goes. See, this is quieter. The real one's not as quiet as that here. And then it goes into super distort here. And then that's very distorted. I got a feeling I might be able to deal with this. Let's try. Remember when we had this going on that were affecting the high pass? We have this gain trim here, or maybe it's down here. This is the maggoty stuff, not worried about that. We have a gain trims thing around here somewhere. It's called trim. There it is. And trim is these things times biquad A times biquad A. So what this is doing is this is dialing back the ramping up. This is changing the trajectory of the ramping up of volume as we get louder. If I take this back out, mid-range and highs should get more distorted again. Everything will actually be more distorted again, but in specific, mid-range and highs will be more distorted again. Because that was another one of your power factors. It was the sort of the slope of how all this works. Oh, can't do that just yet. I'll tell you why. Because we haven't copied this over yet. Here's a reference. Here's how we do. So we're shooting for it needs to be still crunchy as it goes into the high frequencies like that. What we've got is this. Wow, okay. Now remember how this gain level needed to be dialed back? We can do that with this. In fact, we can do that a lot. We need much less of that than I thought, and that's because we were using that power factor. Let's just dial it in on this bright, shiny. Well, before we do that, let's stop it, refer to this. What did that bright, shiny sound like over here? That's high, but I'm not sure it's that high. So by contrast, might have been up here. And boy, how do we not need as much boost. We don't need nearly as much boost as this. Compare to the real one again. And hang on, back to this. Let's pull that op amp cue back a hair. And a little more boost. Poles gain trim might be something we can use here. Wait, do we even still need this? Oh, yes, we do. That had to do with the bottom of things, not the top of things. Max high boost is what we're tweaking here. So I shouldn't have touched that. There's our maximum nasty. This is still wrong and getting louder. Oh well. Maybe that needs to be 0.1. And back to our full crank, I think. Back to the real thing. There's a lot of distortion in here, Joku Sekavon. Like, this is the real device I'm comparing against. Like, this is the real thing. So our low frequencies are when they sit around -12, highs go up to around here. So back over to this guy. On the low frequencies, sit at around -12, we're around here. And we've got to boost those highs a little more. But not this much. highs are up here somewhere. If we want more boosting even. Oh, dude, the real thing shits on the highs. Here, let me go back to this. Let me go back to the correct window. I have to model a real device. You can see the waveform here. The real device, I'm running the filtering on a sample of these drums, this exact clip, which I loaded into the real sampler and then boosted by 24 dB and then 48 dB. So the filtering is being applied to just a completely digitally distorted thing. And that's how I'm hearing what it does to the highs. And here's our mid-range sounds, which are, this is the high passing of this already distorted sound. But then when you start high passing this already distorted sound in the highs, it does this. This is the real one. So I have to clone that. That's what I have to make the plugin do. If you swing it all the way up onto the sound that is this distorted, it's got to do this. And then remembering, of course, that for both of these, the underlying sound is wildly, insanely digitally clipped. And that's what I'm building into this factor, is this. So I need to make, let's see, this. This needs to sound the same. So yeah, where are we at? How are we doing? It's maybe a little grungier. No, the audio is coming from my real speakers. Unfortunately, everything about this audio is super gnarly and nasty. This is all high passes, and this is all high passing, incredibly distorted stuff. The purpose of this whole exercise, and I'm not worried at all if this is chasing people away like crazy. I have to do this for hours upon hours, because once I've got this right, all the same stuff will apply to all the other more nice sounding emulations. So yeah, here's our brightest. And here's what I've got as an emulation. It's definitely a little brighter, but yeah. And then if I switch back to the other pole, here's the same thing for the two pole. So I should be able to turn the poles down and bring it to this, which is still a little bit gnarly. There's still some stuff going wrong there, but let's see if that's true. I feel like max high boost could stand to be a little less. That or frequency is a little too high. Frequency is a little too high. So let's quit out of here and we're going to adjust frequency. It's going to go to exactly 10K. Also, I have a concern. My McAdee style filter has a hotter resonance after the clipping, and I'm getting a lot of really gritty highs out of that. Let's reverse that. See up here? We've got two stages of clipping. Let's put the resonant frequency, the one that's steeper, before the McAdee stage rather than after. Now how's our top end sounding? Again, there's our reference. So real deal. So that gnarly nastiness, how close have we come? Well, one thing about it, we can do a little more op-amp Q. Interesting. Real thing? Emulation. Let's pull this back just a hair. Real thing. Emulation. Maybe a little less gain there. Maybe a little less Q. Compared to the real thing. Hang on. Wrong thing. Everything's a little more filtered than I would imagine. Hang on. Trying to do this thing. And then let's go and reference some of these other ones, such as not as many stages. These are still freaking out, but they're not freaking out as much. All right. That's going to be poles of exactly halfway. Alrighty. Compared to, it's starting to make my ears hurt, man. Here's a nice slow sweep down. So that was the sweep down. Now if we go from here, I think maybe it's also time to revoice this a little more. How's that for a slope? And I feel like, let's bring the max down just a hair, but maybe not quite as much as that. There we go. I'm about ready to wrap up for the day, but I think we have made some progress and that this is going to be something that people can use. And I'm going to finish off by like playing it on a regular piece of sound that's not being wildly distorted. Firstly, back over to this. And back into this. That feels like it. And then the fourth order. Alrighty. So I can refer to that. There's my reference. Now, let's throw on something nice. We'll also see how this works at 44.1K, which is not what we had it set to before. So here's our raw audio. And here's what the Z-plane filters without distorting them insanely would do. Mind you, input gain. Here's your Z-plane style plugin model. If we were able to sample this whole track into it, which we can't because it's too long, you should be able to get stuff kind of like that. And then if you distorted it a bit, or how about something a little nastier? Full overload. going to have to leave an output pad on this. The brightest stuff just goes too loud, especially when you distort it. So people who had a sampler that could be made to do stuff like this. That's the sort of thing. Hey, bro. No, this is an emulation of the emu. I think it's fairly well dialed in. I can probably fine-tune it over the next week or so. But yeah, we've been trying to emulate this sound. Because this is the real thing. That's the real thing. And then this is the Airwindows plugin attempting to clone it. So you got that, and you got this. Or, for less resonance, that's the real one. And this is the model. And that's the highs. There we go. I'm doing the waveform comparisons largely by V meter stuff, but I can show you some of the waveforms. How about I do that? My problem is that with my clip, I can't actually sweep it while processing it. But the waveform comparisons end up looking like this. This is the super bright stuff. And that's it kind of choking out quite a bit. I'm not entirely sure what's causing that sputteriness. Sounds like this. Maybe it's killing the op amp on the output. Here's what the waveform looks like. There's something else that I can do is fool with the low frequency roll-offs, but that's probably better done referring to a low pass. And you can see the way that on this distorted waveform, we got a low frequency resonance in there, which is changing the flat topping. And then as we continue onwards, we start to see these spikes poking out beyond where the flat tops are. And as it gets louder and louder, we're getting this really weird result, which looks kind of like the real device kind of flaking out and not outputting correctly, which is interesting. After all, this is a stereo file, so this stuff should also be here, but it's not. As the energy gets high enough, the output of the real thing flakes out and stops producing anything. And it goes into this kind of sputtery zone where it's no longer working. That is not the case when we're in only 2. Well, no, there's a hair of it even here. But it's getting to this zone where the output of the op amp can just choke. And that might be something that I'll look into doing something about. Under normal processing, we've got waveforms like this where our low frequency stuff, the resonance is changing what looks like a flat-topped wave, because this is starting out being a flat-topped wave. And again, our super loud stuff starts to make the outputs of the real unit choke. Yeah, this is the real thing. This is not my model. This is the output of what the real device does. This is what people want me to emulate. Although I do wonder whether maybe moments like this are perhaps not as desirable. I'm not sure how much of a benefit there is to having the thing literally absolutely die when you push it too far. That said, this is what it does. This is what the real one does. And then again, down into our lower frequency resonances and things. And here is another overtone. Here's an interesting place where the super lows are. Again, this has got to be resonances rather than just only a high pass. Let's open up Raw Meltdown and dial in that effect to see whether it looks the same. So this is where it would be choking and breaking. And this is where it would be kind of wobbling. So what that would look like is this. And as you can see, we've got some of the same kind of wiggles as exist in the real one, because we have this resonant low pass thing going on, and that's what it's making happen. Might be able to hang on to a little more low end, but I'll fool with that at the appropriate time. For now, I'm going to say this is as far as I can go with the stream today, but I think we've made some progress. It's starting to act like the high pass, and the nice thing about that is if I can get the highs acting reasonably plausible this way, then I can also get that stuff acting plausible for all the other things. The band pass, the low pass, so on and so forth. So we'll see. There have been some nice discoveries. And on that note, yeah, I think it's close-ish. It's like, for functional purposes, it's doing some of the same stuff, and I think that's good enough. I do think it could be used in normal instrumental mixing. You don't always have to distort it, although I will be putting in something that will let you distort it if you want. And we will see. I'll be looking at it more closely as I work on it further. For now, I will say goodbye to you for the moment. And I'll talk to you more later. Bye-bye.